Hey, how's it going there, Chem students? This is the Gas Lab Review screencast. The purpose of this video is to give you a synopsis of the three pressure labs that we performed in class. This video is not a replacement for performing the labs physically or watching the screencasts that are actually located on the YouTube channel, which go over graphing and even more specifics as to the data collection. Again, the purpose is to give you a wide-eyed angle of the information that we collected through three pressure labs in class. Please note that the orientation of these labs goes in the sequence from left to right in which we finish these labs in class. So effectively, pressure versus volume was part one, pressure number versus number of particles was part two, and pressure versus temp, that was part three. I will go ahead and erase these labels, but please keep that in mind as we're talking about each of these examples. The pressure versus volume lab was the first lab that we took part in. Let's go ahead and look at the constants. The two things that we didn't change were the number of particles and the temperature. What we did change was the volume and recorded the pressure changes that went with it. Let's try to simulate this in the FETSIM and kind of give you an idea of what we're talking about here. We'll add a few pumps of particles. We'll allow them to spread out. Remember, the two things that we did not change were the temperature and the number of particles, so I won't add any more pumps. And what we want to do is track this pressure gauge as we manipulate the volume. Notice that as the container grows, the pressure gauge goes down lower, meaning that the pressure decreases. As you make this volume smaller, and notice that the pressure gauge increases, the pressure increases. If we flip back to our gas lab summary board, here is the basic relationship between pressure and volume with these constants. As the volume decreased, the pressure would increase. As the pressure decreased, the volume would increase. This made a very specific graph. It was called an inverse curve, and it was the only graph we made that had this specific shape. The shape lends itself to these arrows being flip-flopped. Notice that vertically they are not in the same directions. That is very key with this first lab. This particle drawing mimics exactly what the PhET simulation just showed us. In order to show the volume increasing, notice that we've drawn a bigger box from start to finish. Notice that the two constants are the same ones that we just mentioned. The number of particles is held the same at 3. And the amount of whooshies per particle is 1, meaning that the temperature does not change from left to right. But what do we know? When a box gets bigger, the volume gets bigger, that is, the pressure must go down, and that's exactly what we see. We go from 2 pressure vents to 1 pressure vent. So the specific numbers, when you show change, are not extremely important as long as you show an increase or a decrease in a specific example. Now we'll move on to lab 2, pressure versus the number of particles. The two things that we held constant were the temperature and the volume. The two things that we changed were the number of particles, which in turn changed the pressure. Something to note was that this was called a direct relationship. It formed a straight line. Let's head out to the simulator and see what that looks like in simulation. Let's add some particles here like this. We'll let them spread out. So what you want to do is you want to eyeball this pressure gauge, and the only thing that we need to do to mimic this experiment is add more particles. We're not going to manipulate the size of the box nor the temperature. I will continue to pump this up and down, and please watch the pressure gauge as I do so. We'll see what happens. Notice that with every pump of particles, the pressure gauge increases. The more crowded it gets, the higher the pressure under these experimental conditions. This gives us the relationship as is shown in the bottom here, in this bottom box that I'm currently kind of highlighting. The pressure increases as the number of particles increases. The pressure decreases as the number of particles decreases under constant temperature and volume. Just for good measure, let's go back to the sim and let's see what happens to the pressure gauge as we eliminate particles. Notice that the pressure begins to come down, and this is pretty on par with what we just discussed in terms of our lab summary. The last thing to key in on here is the particle drawing. So to represent this experiment, remember, let's look at the constants first. The volume must stay the same. Notice that the boxes from start to finish are pretty much the same size. The temperature stays the same. Notice that each particle has one whooshy. From left to right, the temperature is the same. What needs to change, though, is the number of particles. So notice that our initial box has 2. Our final box shows an increase of 4. And we know that if number of particles increases, the pressure must increase with it. So box 1 gives you 1 pressure vent. We show an increase of pressure vents equals 3 in the second box. And this would be an acceptable drawing for pressure versus number of particles. Let's go ahead and talk about pressure versus temperature. The two constants of this experiment were volume and number of particles. What we did was we changed the temp, which in turn changed the pressure. The graph that came of this was a direct relationship. It was a nice straight line. And what we can do now is go ahead and set this up in the simulator to see this live. So we go ahead and we pump in some particles. Once we've pumped them in, we will keep that amount the same throughout the trials. Notice that the volume will not change. But what is going to change is the temperature. So let's go ahead and increase the temp and see what happens. So if you watch the pressure gauge, notice that it's going up, up, and up as temperature increases. The particles are visibly moving faster. There are more collisions, more bumper car effects here. And let's see what happens when I actually cool this down. The opposite happens. The pressure actually goes down. So there is a relationship between the pressure and the speed if the volume and the number of particles are held constant. Let's see if our summary says this. Temperature increases, pressure increases, perfect. Temperature decreases, pressure decreases. So how would we particle draw this? Well, remember, we need to start with the constants. Our volume needs to stay the same from start to finish. The size of the box does not change. We have that taken care of. Now, the number of particles also needs to stay the same. So notice that my initial is 3, my final is 3. Perfect. What does need to change is the amount of temperature. So here in box 1, we have 1 whooshy per particle. Here in box 3, we have 2 whooshies per particle. We've shown an increase. And we know that if the temperature increases, the pressure must increase with it. So I've drawn 1 pressure vent in the initial, and then 2 pressure vents in the final to show that increase. Please note that each of these experiments had 2 constant variables, and there were 2 variables that were changed, independent and dependent. Notice that they're color-coded, so they are easy to find here on this colored screen. And that is a hallmark of each experiment. We kept 2 things the same, manipulated a variable that affected the pressure. Pressure was always located on our y-axis. So notice how that holds true to this summary. And the variable that we manipulated was always put on the x, as shown here. Using this summary board is a necessity to finishing an IFV table because you have to look at the pressure relationships at the bottom to select the correct arrows for your IFV table. So as soon as you read the problem, you know what is constant and you know what is being changed. You make a selection out of these three sets of data, and then once again, you must look at the arrows at the bottom, make a correct choice, and stick them into your IFV tables effect row in order to select the correct ratio to complete the problem. Thank you for sticking with me here to the end. Remember, you can pause, rewind, and rewatch parts as needed. Thank you very much.